Good morning, everyone. Am I audible? Am I audible? Rest. Okay. This is done. Good morning. Good morning. Okay. I'm audible now. So yesterday, not yesterday, for yesterday we had done a class on the classification of bridges. Today we'll be talking about the shell structures. What are the types of cell structures? Okay, let me share my screen. Um, this one. Okay. Okay. Why it is coming so differently? Microsoft Edge. Okay. Is my screen visible? Is my screen visible?
Yes, ma'am.
This is called. I don't know. This WebEx is something different today. Why it's updated or what? Shared, stop, recording is done. It's coming differently. This shared and stop. Okay. So today we are going to talk about the shell structure. So what is your cell structure? Let me think this. So what is your cell structure? In building construction, a cell structure is a thin curved plate structure shaped to transmit applied forces by compressive, tensile, and shear stresses that act in the plane of the surface. They are usually constructed of concrete reinforced with steel mesh. Okay. Shell structures, basically, I think those structures in roofs we use, no, these kind of structures in roofs we use, or in some indoor stadiums also you may have seen, or some stadiums, the dome kind of structure is above your structure, any structure, the topmost roof. So those are your cell structures. It can be made up of mixing of steel mesh and concrete reinforced. Okay, so these structures maintain its size and support load even without a frame or solid mass material inside. Okay, these shell structures, what they do, they maintain its size and support the load. The load in case like your, it can be wind load, it can be rain load, it can be some extra miscellaneous loads which are coming during or after construction works. Okay, so even without, and they may not have a frame structure or solid mass material inside, but they can resist your all the forces. Okay, basically they are used in your roofs, and sometimes it may be cylindrical also. Shell structures can be cylindrical also, so that will be used in your. Okay, so that will be used in your what, pipe structures, the cylindrical ones. A shell is a building that is empty from inside. These shell elements are typically curved and assembled into a large structure. So basically, as I told you, the shell structures, these are what? These are your curved structures. These are your thin curved plate structures which are shaped in different shapes. It can be a dome kind of structure, which is used in your, you have seen maybe in your stadiums, above the stadiums, and some kind of indoor stadiums, outdoor stadium, indoor stadiums mainly. Okay, so or it may be some main gateways. Suppose there is a large main gate of your any entrance. In that case, you are having these kind of things. So these are your curved plate structures, which are also known as your domes, or it can be in some monuments also you can see these. There may be some dome kind of structures. Sorry for this bad drawing, but like this. Okay, so those are your cell structures. A cell structure is a building that is empty from inside. These portions are empty, right? These portions are empty. Here also these are empty. Here also these are empty. And below this we are having what? Below this we are having the main structure with columns, etc., right? So these are your shell structure. And these shells elements are typically curved and assembled into a large structure. They are lightweight construction using shell elements. Here we will learn about cell structure, types of cell structure, and much more. Okay. Now introduction to cell structure. This was a basic like what is your cell structure, curved, plane structure. But what is your coming to the introduction of your cell structure? In the cell structure, a thin shell is defined as a shell with a thickness that is smaller than its outer dimensions. Okay, the suppose if I'm talking about these dome kind of shell structure, the thickness of these this thin curved surface or the plane is, this thickness is very small as compared to its the overall dimension you're looking. Okay, so these are your cell structure. This is called your cell structure. In a thin cell structure, the deformation is not as large compared to the thickness. The main difference between cell structure and plate structure is that within unstable state, the shell structure have curvature, unlike the plate structure which can be flat. So the main difference between your shell structure and your flat structure is what? Your cell structure gives you your this curve you're looking. This curve, they have this curve, but in your other plate structure, what happens? This is your flat, this upper surface is your flat, which is your plate structure. Okay, but these are your shell structures, okay, which have a curvature. Always it will have a some kind of curvatures in them. The cell structure will have semi curvature, full cylindrical curvature, or it may be cylindrical completely. Okay, so these that can that those are called your cell structures. Now, membrane action in a cell structure mainly due to plane stress, although flexural deformation may result in secondary causes. Okay, due to the plane stresses, your the membrane is acting in your shell structure. Uh, Although the flexural deformations which will obviously happen, that may result due to some secondary forces like sometimes there may be some repairing work, etc., above your cell structure. So in that case, the flexural deformation may take place. Okay, now coming to the types of your cell structure. Mm, Coming to your cell structure, what is there? This is your types of cell structure. Cylindrical shell, it can be your cylindrical shell, it can be your multiple cylindrical shell, knot like shell, asymmetrical cylindrical shell. So what is your cylindrical shell? The cylindrical shell in which the stationary curve called as directrix or moving curve called as genetrix is a straight line. Semi-ellipse, parabola, arch, circles, cycloids, catenary, horseshoe shape are the examples of common cylindrical shells. Okay. So, when you have a cylindrical shell, what it means, you have in which your stationary cure called as directrix. Directrix means what? Any fixed point, any fixed point of a structure. Like suppose if you have this cylindrical, if you have the cylinder, this is your central fixed point, right, through which you have your radius is same. You have this radius, okay. You have this radius is same, so this is the fixed point here. Your this middle center one is your fixed point, that is known as your directrix. So a cylindrical shell will basically have a stationary, that is a fixed directrix, this one. So obviously cylindrical shell, that means whenever it is cylindrical, it will have a the stationary directrix or moving curve. Moving curve means called generatrix generatrix, okay. So generatrix means what? It can be any, suppose cylinder, if it is cylindrical shell, if it is cylindrical shell, it can be your moving curve, because if it moves from here to here also it is same, from here to here also it is same. Okay, so in that way, in whichever direction it moves, like cylindrical, it will be, if you see the cross section, it will be something like that. So if you have this fixed point here, which is your directrix, from here to here, here to here, here to here, it is all same, right? So moving curve, it can be when you move your curve from here to here, here to here, it is all same straight line. So this is your what? This is called your generatrix. Okay. So this your cylindrical shell can be parabola, arch, circle, which will have always your this kind of stationary directrix or generatrix. Okay. So now coming to your multiple cylindrical shell, this is cylindrical shell which will have this kind of shell structure, will have one cylindrical shell. It may be in your some underground structures you're looking, when you have this kind of shell structure, from where you people pass through this structure, cylindrical structure, and outer surface you have all waters outside. So those are also a kind of your cylindrical shell structure. Okay, and multiple cylindrical shell means when you have different multiple cylindrical shells, right, combined together to form a different structure. So multiple cylindrical shell is a series of cylindrical shells that are parallel and transversely continuous. Okay. Now, north light shells. What is a north light shells? The north light shells in which two spring ring are provided at different levels is called the north light shells. North light shells, generally these kind of structures you may have seen, these like this. It's like this, facing towards the north side for the lightning purpose. The provision of the curve at different levels, because see if this will be somewhere little bit down, this will be little bit up, this will be little bit down, like that. I'll show you, wait, one structure. Best example of that is here, this one. You see here, this in Sydney, this opera house, towards the north side it is facing in this is your north light, because so that the light can pass through this. Okay, so that's why these are known as your north light shells. Now asymmetrical cylindrical shells, what are those asymmetrical cylindrical shells? These asymmetrical cylindrical shell structure is not symmetrical about the ground. Okay, so you have what? Asymmetrical cylindrical shell, they are not symmetrical around the ground. So when you have the ground, suppose this is the structure, the columns you may say. So what happens? You will have here your crown over the structure, but this is not cylindrical completely. If you see the cross section, it is not completely cylindrical. It may be semi in this way, or it may be different kind of, this okay, sorry, this, so it can be your this structure, it can be like this, it can be like these, it can be like these, it can be like these. So it is not symmetrical. If it would have been symmetrical, it would be, those symmetrical cell structures should be like this, like this, like this, same the same dimension, semicircular curves, or the cylindrical, completely cylindrical also it can be. So these are your asymmetrical, these are your asymmetrical cylindrical shells. Okay, barrel shells, this barrel shell is symmetrical about the crown. Okay, so and also your this barrel walls, these are also same, where you will have walls is nothing but your, the crown, when you have this crowns over columns, etc. So these are your walls, these inside parts are known as your walls. Okay, so you have your barrel walls are most useful. Hmm. So a barrel shells means what? You have a suppose structure, a column suppose here. Barrel actually means what? When you have something bulging out in the middle, in the center, like suppose this is the center of your these between these columns, this is your center in a structure where you're constructing. So this is the center. So you have your, it is bulging here at the center. So this bulging out, it can be like this also, it can be like this also, which is bulging at the center is your barrel shell. So it can be different names, your shell structure can be of different names. Barrel shell. Now barrel walls means what? Barrel means bulging the center is bulging, and walls means it is same kind, but the inside roof part, or the this thing where you have this bulging portion at the center, there you have the inner portion, that is your walls. Okay, so which are useful for the shell structure because of the greater span, because of the greater span capacity of up to 50 meter with minimal material. Okay, when you have this walls, that means some arch kind of things with the barrels, that means bulging outward, but you have some arches also there. Okay, so that is your barrel vault. So that is your barrel vault, and it is useful for greater span capacity up to 50 meter with, when you have, your structure is very you have a structure of a greater height. In that case, you can use this barrel vault shell structures. Okay, sorry. Now, coming to your short shells and long shells. Now, we are talking about different types of cell structures. So, based on their length, you know, or the span, it can be your short shell or long shell. So, the number of terms has been developed to describe cylindrical shells depending upon its short span and long span. Shells, if the span length is short, then it is termed as short. As the name suggests, you have your long shells if the span length is large in comparison with its width. When your span is greater than your width, okay, then it is your long span. Now, domes. What are your domes? Dome is another kind of structure. From that time I'm talking about dome only. But specifically when you talk about domes, a dome is a space structure. You have seen the space uh, spacecrafts or spaceships, where you have the structure, how it is, this something like dome kind of shape. So that is your domes, the dome shell structure. Okay, a dome is a space structure that covers a more or less square or circular area. It can be semi square, it can be semi circular, them like sphere kind of domes. The domes are attached to a surface generated by a curve of any form revolving about a vertical line. When the surface has a double curvature that gives rise to a hard and strong shell. I'll show you the domes. Okay, I have opened, where is this? This one, I think, no? This one. You can see here the dome structures. This is a kind of dome here, but this is a square, some semi square flat domes. Okay, this is another dome. This is, you see, the dome structure in the stadium. You can see, or it can be anything, not only stadiums, it can be any different structure you're constructing, but you have this cell structure above that. This is a dome structure. It is looking like a space shape is designed in this way, right? So these are your dome shell structures. It can be in this way also. It can be semicircular, it can be circular, it can be this square, semi-square, this square kind, but you see this edges are rounded off. So these are your dome shell structures. Okay. Now, okay. So you have the dome structure we have seen. Okay. We have seen the dome structure. Now coming to your this one, intersection intersection shell structures. Okay, there we are talking about different types. So another one is your intersection shell structure. The structure effectively of the intersection shell is dependent upon the angle of intersection of the surface. If the angle is small, a rip fanned by adjacent elements of the original shell is much larger than the adjacent shells on each side. And if the angle of intersection is too large, it is called a shallow intersection. If the angle of intersection, if you know the shell structures when two not continuous, but when you are mixing two shell structures together with an intersection shell, so it is dependent upon the angle of intersection. Okay, the structural effectiveness is dependent upon the angle forming by the intersection of these surfaces. If the angle is small, what will happen? A rib fanned by adjacent elements of the original shell is much larger than the adjacent shell. Okay, and if the angle of intersection is too large between the two cell structures, it is called a shallow intersection. If the angle of intersection is 90, it gives a rigid rib. Okay, now shell arches. So many types of cell structures are there, you know. Okay, this is the last one, 10 and 11. Shell arches. Shell arches are in the same category as small shells. Basically, you know, we are talking about different types of shell structure, but somewhere or the other they are similar. They are same kind. So they're shell. They are similar, like dome. They are like, you know, the curved. They are. They can be continuous, they can be cylindrical. So you know, when you know one kind of cell structure, you can describe the other types, because they are based on the small criteria. They are differently classified, or you can say that they are different, they are separately called by different names. Okay, so this is another one, shell arches, but they are same, like, you know, the shallow, you can say the shell arches are in same category as small shells. You can call them as small shells also. If the, because arches, you know, the arches are always there in the vaults also. We have barrel vaults also, we have talked just before this. So in that case also, you know, the shells are there. If the stresses are mainly compressive, all thicknesses can be made. Okay, so all thicknesses can be made much smaller than an arch. When you know your cell structure will have only mostly the compressive forces, so in that case you can do what, can be your thickness can be decreased. Okay, shells are not very efficient structure for the high value of bending moment. When you have when you know your bending moment can be very large, in those cases your shell structure is not provided. Okay, shell structures are basically what, when you have to, for a decorative purposes, for the show of the structure, for making it something unique, in that way we are using the shell structures. Translation shells. A translation shell is generated by a vertical curve sliding along another vertical curve. So you have a vertical curve, another vertical curve, when it comes on that, it is a translation shell. Curves have different shapes, such as circles, ellipse, it can be parabola. We have already seen there can be different types, you know, of the cell structure. The curves can be your circles, ellipse, and parabola. Therefore, vertical segments are all the same as opposed to a round dome in which all vertical segments differ in height. Okay, when we are using a dome, the vertical sections are everywhere different because they have different heights, right? But in case of the curve, when we're using, it can be curve, but it can be circular or parabola or ellipse. Their vertical segments are all of the same. Okay. So in short, translation shell is simply a square dome in which the shape is, because translation shell, as here it is mentioned, in translation shell, what happens? Your this vertical segments are all same. So obviously when you have a different the curve or the dome is too high or too big, what happens? You have different heights, here small, here. Okay, when you have a dome like this, you will have here height is different, here height is different, here at the center your height is different. So it is the vertical segments are of different heights. But uh, here in the translation shell, what happens? Your vertical segments are all of this same somewhat. So in short, if we say, it can be in this way, it can be in this way. Okay, so it is nothing but like I showed you in that figure, one of the figure I showed you previously, which was your square, semi-square kind of figure I have showed you, where these heights are always same. This one, you see this height, this height, this height, all these are in the same straight line is here. So this is the same height is here from here to here. Only this portion is curved little bit at the bottom. So it can be said to be square dome only. Okay, so this is nothing, square dome also it can be said. Or when you have, okay, you have translation shells, it is also known as translation shell. Okay, so we have 5 minutes, but I'll just complete it. Few points we have. Application of shell structure, where we have the application of shell structure is where we can be it can be used in fuselages of aeroplane. Fuselages is nothing but your the frame of your the aeroplane. When you have the frame of your aeroplane, then only you can put the other parts of the material, join and make it a aeroplane. So that the fuselage of an aeroplane is nothing but the body or the entire frame of your the aeroplane. Boat halls is nothing but when you have you have suppose ship, you have this is your ship. This portion, the down portion, this portion here, this boat, you have this portion. These are your halls, vault halls. This is greater in height, already. So these can be used in this kind of boat halls also, your structure. And a roof, to roof structures in most of the in some building structures. Okay, fuselage is your frame of your aeroplane. When you have this frame, what happened? When you have this frame, so when you have this frame, you can put all the different parts of an aeroplane, and then it will become, this is the application. This frame, when you're making now, this is your fuselage. Your shell structure can be used in those also. So the cell structure examples, best examples till now, if you can if I show you, is that your this one, this type of structure which provides a fantastic architectural view, is your this opera house in Sydney, is one of the best example of your shell structure, which is in Sydney, the world famous thin shell structure. You see here the north light structure is used. North side it is facing, and also it can be you can say it to be a barrel halt structure, cell structure. Another one in India is your this one, the Lotus Temple at Delhi, also a good example of a shell structure. See, these are your shells, these are the shell made up of different shells. The shells can be always either this shape, which is here in the inward side it is moving upward, that is bending on the center. Here also it is bending on the center. It could have been circular, it could have been your square, semi square, or it could have been completely cylindrical. But here it is differently made, but this is a cell structure but differently made like a barrel vault, you can say, and it is vertically placed here, it is horizontally placed here, so forming a beautiful structure architecture. With respect to the architectural point of view, it is a very good example for your cell structure. So this was your cell structure. So conclusion is what? A cell structure, also called plate structure, are lightweight construction using shell elements. Usually these curved elements are assembled to form a large structure. Okay. So shell structures, small cell structures, you see, these not small actually, different members of cell structure. This is one shell, this is shell, this is shell. So forming, combining these different shells, this lotus temple is formed. So forming, joining different shells, we are having one beautiful structure. So this one is also your Sydney one. Okay, so let me share your attendance link first, if it's possible, or else I can share in your WhatsApp group. If the link gets closed, if the meeting gets closed, you can, the WhatsApp also you can give. Okay, so wait. Building construction practices. Okay. Okay, I have shared the link. You can go and give your attendance. Okay, 396. Okay, Benison, Deborah.